Let's use calculus to help us sketch a graph of f of x equal to 2 minus x squared all cubed. Now for a polynomial like this, the most useful tools are to find where your function is increasing and decreasing. So, to find where it's increasing and decreasing, we need to find the first derivative and find where it's positive and negative. The derivative in this case is 3 times 2 minus x squared squared times negative 2x. Remember, this last part here comes about because of the chain rule. So cleaning that up, let's write that as negative 6x times 2 minus x squared squared. And let's set that equal to 0 and solve to find the critical points. Well, this means either negative 6x is 0, so x itself is 0, or that 2 minus x squared squared is 0. Well, that happens when x squared is 2, so x is plus or minus the square root of 2. So those are our critical points, and we'll put them all down on a number line here. So here's negative root 2, here's positive root 2. And now we're going to do the usual thing, where in each of these 4 ranges, we are going to plug some point into f prime and see whether we get a positive or a negative value. So for example, if I plug in, say, a very large negative value like negative 100, well, negative 6x, when I plug in a negative value, is going to give you something positive. And if I plug in a value like negative 100 into 2 minus x squared, well, that'll get me something negative, but this second part is itself being squared all the time. So that's always going to give you a positive. So overall, we get a positive. We have a positive times a positive, and we got a positive. Similarly, for x values between negative root 2 and 0, it's still the case that this first term will be positive, and since the second term is always positive, that's going to be a positive. And then going through the same process for the other two, you'll get negative for both, because in both cases, negative 6x will be negative when x is positive. The second term is positive, and so you get a negative times a positive for both. So we have that f is increasing. It kind of levels off for a second, and then it continues increasing. Then it's decreasing, and then it's decreasing. Okay, so that gives us some idea about the shape here. So how can we use this to try to plot the graph? Well, it's helpful to maybe find some of the intercepts. So again, the function here was f equals 2 minus x squared cubed. I mean, more or less it boils down to it's useful to find at least a few concrete points on the graph. Here, for example, we see that at x equals 0, the graph goes from increasing to decreasing, and so it's useful to know what f of 0 actually is. So in this case, f of 0 is 2 minus 0 cubed, so 8. So that gives you the y-intercept. In other words, we're just saying that the point 0, 8 is on the graph. This is also already in a form where the x-intercepts are easy to find. So remember, the way you find x-intercepts is you set f of x equal to 0 and solve. And for some functions, this can be really complicated, but in this case, it's not that bad. Because if 2 minus x squared cubed is 0, well, that means that 2 minus x squared is 0. And so x is plus or minus the square root of 2. So that at those two x values, we have a point on the x-axis. So now we can actually start sketching some of this. So let's draw a set of axes here. So we said that We had a local maximum up here at a value of 8. We know that the graph crosses at negative root 2 and positive root 2. And actually not only that, but remember negative root 2 and positive root 2, those are actually critical points of our function, where the derivative was also 0. So the graph is increasing, and then it kind of levels off for a while. Increases, decreases, level, decreases. Right? Of course, these little bits of being level, they're momentary. They're not really little pieces like this, but it's more like some just little second of being flat. So between negative root 2 and positive root 2, the graph is increasing and then decreasing with this local max here at 8. But in fact, this little bit at the end and this part here is not quite right, because the graph was increasing before, leveled off, and then started increasing. Here it's decreasing, levels off, and then starts decreasing again. Maybe I didn't emphasize that very well right there. That should look something like this, more or less. And if we wanted a slightly better picture, well, you might plot a few more concrete points. You could actually find, say, what is f of 1 and negative 1. And if I were using real grid paper, you could plot sort of a really nice graph of this. Okay, so for polynomials, often just finding the first derivative or the first and second derivative information is kind of enough to get a good picture of what's going on. So next time we'll look at an example of a rational function.